I think that you have really what we call white paper. The idea could be, as I mentioned before, working on solutions that can be easily installed in a production floor, keeping in consideration the limitation coming from the layout. Our layouts in RRP industry are quite open, so there is quite a lot of space. When we try to move the same innovation in a cigarette factory, the density of the machine is a bit higher, and this is also one of the reasons why the noise normally in a cigarette factory is bigger than RRP. So solution that can be created in these highlands, in the silent highlands in the shop floor, working on absorbent materials, having attention on the fact that tobacco dust is the nest for insects, particularly one that it's very, let's say, aggressive and needs a, let's say, very strong pest control. This bug, this beetle is called Lasioderma. So it's our first enemy, and then having a certain materials as the absorbent can create or facilitate the introduction of this infestation. So we are open also to solution about electronic noise abatement or any other element that can improve the comfort of the workers and at the same time make the communication easier. So this is a nutshell. Other elements that can help you is in the new generation machine, we made huge improvements, as I mentioned at the beginning. So certain solution might be dedicated to RRP business. Others might be more suitable for conventional cigarette factories, where in general the noise level is a bit higher. Fortunately, we didn't experience so far occupational illnesses related to ear loss, mainly because of the discipline, also the organization of the work that allows pauses to relax your ears when you are exposed to the noise. I can say that the use of earplugs is one of the most respected rules. It's very difficult to find people not wearing them. So this is in a nutshell what noise means for Philip Morris and why we would like to find a solution to free up our organization to have better communication, less stress, and a healthier life. So we move to the next challenge, and I would invite our colleagues that are connected online, Andrea and Arjun, to present the next.
Thank you, Gianluca. Good morning, everybody. I'm Andrea Bruno. I'm a senior lead in environmental engineering solutions. I'm going to introduce the second challenge that is about energy and environmental impact reduction. What is our challenge is easily stated. As you see, we have we have a challenge that is to achieve carbon neutrality in our operations by 2025, and this is the challenge for the midterm. And then in the longer range, we aim to net zero across our entire value chain. That means Scope 1, Scope 2, and Scope 3 by 2040. Now, how do we do that? We actually have a three-pronged approach. We reduce, so we maximize our efficiency. We want to reduce our consumption, but at the same time, we aim to reduce the usage of fossil fuel by switching to renewables. So promoting the self-production of electrical energy or storing of electrical energy and not just electrical energy. So once we have done these first two steps, of course, and we have maximized our emission reduction, we will compensate our, let's say, unavoidable loss, unavoidable emissions using offsetting and insetting projects. So now I will leave the word to the stage to my colleague, Arjun Arya, please. They will describe the challenges in further detail. Thank you.
Thanks a lot, Andrea, and thank you all for joining. So much like Andrea, I'm a part of the environmental engineering team and looking at innovations as such. So to Like Andrea has explained, if you think of us like an energy system, there are two parts of the energy. One are the electrons that we consume, which is the electricity, and then we also need a fossil fuel for steam production, right? So we have electricity for utilities, and we need natural gas or some other fossil fuel so far that is being used for steam production. Um, that being said, we are trying to minimize our footprint, right, as per the ambitions, and also looking for efficient solutions that can be put on site. So if you saw the chart before, it was basically we want to reduce the footprint as much as possible. And the first part of this challenge, or the three-pronged challenge, is what can we generate maximum on site, right? Could be new generation of PV technologies. I've just given some pictures to give you some ideas, right? But again, not limited to it. It could be maybe micro wind methods. It could be something completely different. It could be using compression of air based on a temperature delta, right? So things that can be done on a factory premise, which are also low footprint from their side and are modular to be deployed, right? This could be a new orientation, a new chemistry. It can be many other things, because the issue with factories is we don't have much space, right? So we want to use as much of every surface that we can, every resource that we can, to reduce our dependence on maybe the grid or fossil side, right? So this is the first challenge, which is looking at next generation renewable energy generation technologies, modular scalable, and that can be deployed on various surfaces of our plants. And you can find all our plants online, right? So you can take the Crespellano plant as an example, but just for you to have a visualization on Google Maps, how our plant looks like. Can move to the next one. Right. So if you have generated the electrons, right? The biggest challenge with renewable energy is that both the sun and the wind, they're not shining and running all the day, right? So there is always a peak time where they're generated, and then we need a buffer because our factory is running almost 24 hours, right? So we need the energy 24 hours, which of course the grid can provide, or the other sources, which are traditional sources of energy, can provide. But we need to go power to X, or how do I say, energy storage, and specifically long duration energy, right? So what is called as long duration in literature is basically beyond at least more than 4 hours, right? It can even go up to 24 hours of energy storage. So there are various ways of doing it. You could do it thermally, mechanically, chemically, and electrochemically, right? So if you're going chemical, you might even produce a molecule like hydrogen on site. And if you're using your solar or wind to generate that molecule, you can save it to be used at the later point in the day. And this challenge is really the first challenge. The electrons need a home to be, kept in for a long duration discharge, right? And of course, with energy storage, you can do many other things. You can do peak shaving, you can do energy shift applications, you can do a bunch of different things. But also, it is about resilience. And what is important here is that we are not just talking about electrons. So we need steam, right, in our process. So you could also drive it from a thermal side to compensate for the natural gas that we're using, right? So the electrons could be converted to heat later on and then be used, right? So this is an open site where some form of storage in various open points. So we are not limiting to just hydrogen or just a form of energy storage. And we don't qualify standard technologies like lithium ion in this, just to keep that clear, right? So because we are looking at those next generation technologies that can go beyond 4 hours, because until 3-4 hours, lithium ion is very interesting, but we need something longer, right? And of course, if you want some literature, I've put the source here. It's a good article that you can check for some literature on this side. I'm guessing you already have the information. The next one, please. Right, so this is the last one, and this is where Andrea actually started, efficiency, right? So what can we, actually the name of the game is exergy, if you look at thermodynamics. So we want to reduce the delta between us and the ambient, right, in a way to use all the sources of energy around and in our systems at the maximum to balance our system, right? So when I consume X megajoules of energy, I want to ensure my system is built with so much efficiency, be it with heat pumping technologies, high temperature heat pumps. It could also be with software-enabled IoT systems that enable you to detect failure or detect heat losses, right? It could be insulation, so it's quite open. And industrially, there are many standard efficiency methods, right? Like if you have flue gas, you want to recover the energy from it. But we want to look at something out of the box, right? If you have a heat pump which can take a low temperature heat and pump it to much higher temperatures, within, let's say, a certain, I mean, we are not very high temperature industry, yeah? So we are well within 200 degrees in our process. So essentially, we would need a source that pumps it up. And of course, any other relevant efficiency related topics. So it's quite open, this one as well. And I think that is the end from our side. So yeah, thank you.
So thanks to Andrea Bruno and Arjun Arya. And now we go on with the challenge about circular economy and reuse of industrial waste with Federica Guidi.
Okay, so good morning, everyone. My name is Federica, and I'm a warehouse operations specialist. And as a logistics department, it's really important for us to really achieve zero losses, and in particular to reduce our environmental impact through waste reuse and recycling, as we're owning as logistics department the contract for waste disposal. So this is not only related to production plant, but might also be related to, for example, the final consumer. So an example, heat spots coming from the final consumers. So we can see the main codes that we would like to focus on for this challenge. So the first one is waste containing tobacco materials. And as example, we can consider the packages that are scrapped from productions, as well as some tobacco roads that can contain paper, plastic, or in some cases, even metal strip. And then we come on with the second one, so the cigarette filters, and they are also scrapped from production as non-compliant, and they can contain cellulose acetate. The third one are the sludges from industrial wastewater treatment, and those are mainly created, as Gianluca mentioned earlier, in our primary processes, mainly from slurry preparation and also flavor kitchen. So the fourth one is the plastic packaging. So for example, the plastic film wrapped outside of the heats packages. And the very last one are our lab chemicals. So the lab is currently ensuring the quality and conformity of the hits. So they're carrying out some very specific analysis in order to make sure that the batches are really conforming and they're good to be sold, among some other activities. Okay, so if we move on to the second slide, we can see in the table on the left the codes that we mentioned earlier. And during a time horizon of 1 year, we also consider the total tons that were disposed, as well as the percentage of cost. So what we did was we considered the time horizon, again, from January to December, and we actually had available the data from January to October, and then we estimated accordingly the ones related to November and December that were not available. So for example, you see the first code. I also wanted to mention how we calculated the disposal cost. So if we consider 100% the total cost for waste disposal, for example, we can see that 50% is related for the first code. So you see the first one is the most impacting ones, both in terms of tons and percentage of disposal cost. So the current process that we actually have in place is to create biogas from that code. Then if we move on with the filters, we currently do not really have a process in place in PMMTB, but what we're seeing is that our affiliate in Romania, they're currently using the cellulose filters and cellulose acetate from the filters. They're selling it to IKEA, and then IKEA is producing the padding, so the filling of the jackets, which are then sold to the final consumers. Then regarding the sludges, there's not a process in place, but we are currently evaluating the possibility of creating energy from it. The only problem is that there's a lot of water in it, so it's very rich in water. So the water will need to be removed first in order to increase the energy power to the slurry itself. Then we're also having plastic packages in lower percentages, as well as lab chemicals. And then we group some other materials that are not really individually relevant, but altogether they create quite a few of tons as well as disposal costs. So we can see the as-is state. If we compare the as-is state with the to-be one, we can see that currently we're having a recycling rate of 76%. And how we calculated that is we took the total cost, the total kilograms of waste that has been disposed under the bucket recycling out of the total ones that have been disposed. So 76% is pretty impressive for a manufacturing company, but still we really want to improve that because we're also facing quite high disposal cost in the as-is state. So for the to-be state, so this is why you guys are here, we're aiming for a recycling rate of 85%, which I know is really ambitious. So we're really counting on your contribution for this, which is present in our 2023 master plan. So we're really committing to this, as well as reducing our disposal costs, which should be directly related to decreasing the weight of the waste that we're actually disposing, and therefore we're gonna have less disposal costs. So finally, I wanted to leave you with some examples of companies that we're considering as benchmarks for this challenge. So for example, one is creating from cigarette butts, glasses, and umbrellas, so just general objects. Then the second one is creating from agro-industrial waste paper or clothes for the fashion industry. And the very last one from wastewater is creating water, clean water or biogas. But these are just some inputs. So innovation is the keyword here. So we really cannot wait for you to share your ideas with us to really help us give waste a second chance. And we also brought some samples of the different codes. So if I may share some of them with you. I don't know if you can see them from the camera. Where is it there? Okay. So these are, for example, for the first code. And then we have the filters. And then we also have the plastic, which I'm not going to show you because it's, plastic, you know what it is. And then we're having some other ones. We have the slurry. So it's, I don't know if you can see it. If somebody can maybe mention that, if you can see what I'm showing you. And also we have some other goods, but.
Yes, we can.
Yeah. We kind of wish you were here to really see it in person. Okay, so thank you so much and good luck on your challenge.
Thank you, Federica. And now, so those were the 3 innovation challenges. And now, the last part, Nicole Monti, head of Startup and Spin-off Unit at AlmaCube, will tell you about how to apply to this call.
Hello, everyone. I'm Nicole. So let's see who can apply to the call. So not only startups and spin-off are admitted, but also higher companies, also SMEs and corporates which have an innovative solution. All the companies that apply must be formally established, so we will not admit teams that are still in a constitution phase. Regarding the location, we will accept companies based in Europe or in Israel. And regarding the scope of your solution, of course, they must be consistent with one of the 3 challenges proposed by Philip Morris. Regarding the technology readiness of your product, we will prefer, of course, companies which are still in a development of a prototype or have already a product applicable to the market. So to apply is very, very easy. You must go on the main page of the call, so futuremanufacturing.it. Apply. You must click on the apply button, or in Italian version, partecipa, and you will be redirected on F6S platform. Here, if you don't have already an account, you just need to log in with Facebook, LinkedIn, or email. And you will need before to fill out some question from S6S, and then you will have the chance to fill out the question for the call. So the application form is very, very quick. I think you will not take more than 5 minutes to submit. And remember to submit, of course, before December 19. If you can apply maybe in these days, next week, so before the deadline, you will also have the chance to receive support from our side. So don't hesitate to contact us. You can also directly contact me at nicole.monti@almacube.com, and we will support you in your application if you need any help. So registration is free of charge, and also the participation in the co-design program. So we will select up to 3 companies that will access the co-design. Participation is free of charge, but they will need to bear some costs of travel and accommodation. But it will be really a limited number of travel, so maximum 4 days, I would say, in Italy. But you will also receive a sum of 5,000 euros each company to support you in bearing this cost of participation. And participation is equity free. So as we already said, Philip Morris is not interested in taking any equity in the company, is not acquiring capital. So it's really just a win-win collaboration that could lead to a supplier contract. So let's see which are the next steps. The application deadline, as we said, is December 19 through the online form. Then after Christmas holidays, the jury will select a short list of maximum 15 candidates that will access the pitching session. The pitching session will be online in mid-February. And you will pitch in front of a jury composed by Philip Morris and other partners. At the end of the pitching session, we will select which are the 3 winners that go to the co-design program. And the co-design program will take place from end of February to end of April, in order to arrive ready for May 3rd to present your proof of concept to Philip Morris. We will decide if you are admitted if they want to finance your proof of concept, and then start a collaboration.